What's up, donks? Welcome back to Sudoku with Shui. My name is Sudoku. Today we have Chesapeake by James Sinclair from Artisanal Sudoku Volume 195. All right. From normal Sudoku rules apply, we have dynamic fog and we have cages. Okay, so let's go. So normal Sudoku rules 1 to 9, every row, every column, and every 3 by 3 box. Ignore that one. We have dynamic fog. So normally, regular fog is if you enter a digit here, it clears out these digits that surround it. With dynamic fog, cells elsewhere could clear. So if I do this, then these 4 could clear. If I do this, this one could clear. If I do that, nothing could clear. So this is going to be a little difficult. And then we have cages. So the digits in the cages have to sum to the digit in the top left corner. So that'll tell you that, and you can kind of see like the little artifact in the bottom right. So we know that the cage goes that way and then down, that way and down. All right, let's see what we can do. I'm going to restart the timer and then we can go. Okay, so 6 can only be 1, 2, 3. 7 can only be 1, 2, 4. 6 can only be 1, 2, 3. So if this is 1, 2, 3, then 4 has to be, we know 4 has to be there. So this cannot be 4. Then we have 1, 2, 3 there. 1, 2, 4. Okay, so 3 has to be here, I think. Let's figure this out. Because if this is 1, 2, and then 3 would be there, what could those be? Nothing. So these cannot be 3. Wait, right? No. Hang on. 1, 2, 3, and 4. No, this cannot be 3. 3 has to be here. There it is. So 3 has to be there. So 1, 2, 3, 4. Then we have another 1, 2, 3, 5, 6, 7, 8, and 9. All right. How do we get there? How are we going to get there? So this. So this is going to be here. This is going to be one of those two. Okay, so let's call, I'm going to call it that. So this is going to be on one of these two. So then this is going to be here. This one, I'm going to go pink, which puts pink there. And then that's going to be pink. Okay, so then I can place this as a 3. Yeah, love that. Okay. So then another one over here, this is going to be 1, 2, 4. This is 1, 2, 3. And then that's going to be 1, 2, 4. So 1, 2, 3, and 4. 1, 2, 3, and 4. So 4 has to be here. 3 has to be here. Okay, so that can't be a 3. That can't be a 4. And then 4 has to be here. And then 3 has to be here. So that's not a 3. So this should be the 3. Oh, that's frustrating. Because dynamic fog, just because I put the 3 there doesn't mean that it has to clear. So I think, right? So let's clear that out. So because if this is not a 3, this would be 1, 2. Yeah, this has to be 3. I'm going through. So that's not a 3. So that's a 1, 2. 1, 2, 4 triple. So then this one would have to be pink, and then this one would have to be green. So then this one is pink, this one is green. Which puts, this one would be pink, so then the 4 would be here. Okay. So then this is green. So then this would be a 4. All right, and then we cleared out a 4 there. So then this is a 1, 2 pair, which puts this as pink, and then this one would be green. So then this one cannot be pink, so this one is pink. So then that cannot be a 4. So this is a 4. Then we have a 1, 3 up here. So that's a 1, 2, 3 triple. Okay. Oh, then this is going to be pink. Can we, and then this is pink. So then this cannot be a 3. So this is a 3, and then I can do pinks would be 1s. So then greens would be 2s. So then this is a 2, and then that's a 3. Uh-oh. Check mark, must have messed up. Whoa, puzzle's looking good, but I'm not seeing... Oh, there's an 11. Oh, okay. All right. Got it. So then that's... Gonna clear that, and so that's there. Okay. So we have an 11 cage. So what... All right. So with an 11 cage with a 1 on there, so then the remaining digits have to add up to 10. They cannot have a 2, 3, or 4 on them. Actually, 4 could be here. So it could be 1, 4, 6. Could not be, I think it has to be a 1, 4, 6. I'm going to place a 4 here. And then a 6 here. All right. Love it. But nothing else is cleared. That's not good. Can I can pencil mark 4s here. All right. 4s here. 4s there. So then 4s will go down here as well. What about down here? 3 spots for 4. That's not going to work. 3s will be here. 3s are there. Oh, this is a 3. So then I pencil mark 3s there. It's a nice little X-wing. Okay, if that's a 3, then this has to add up to 11. And it can't be, obviously can't be 110, can't be a 29, can't be a 38. So this would have to be a 47, which can't be, or 5-6, which can be. So that's going to be a 6 and a 5. So then pencil mark 5s here. Okay. So 4s are up here, 3s are there. This is 7, 8, 9 triple. How many 4s can I do in here? Just here, and then down here as well. Okay, so 4s are going to be like this. Sixes are here, and here. Ah, Conyo, that's a 2. Okay, I gotta... So could this be a 9? That would have to be a 1, 8, impossible. 2, 7, impossible. 3, 6, impossible, and 4, 5. So this has to be a 2, 8. Then this becomes a 5, 7, 9 triple. And then this is a 4, 7, 9. Okay. Okay, so we have 1s are done. 2s. Where are we missing a 2? Right here. That's a 2. There we go. So that's going to be a 4. That's a 4. Clear that out. This is another 2. Okay, so 23 can only be 6, 8, 9 triple. So then we can place this as a 9. That's going to be a 4. This is a 6, 8. So then this will be a 7. This is a 5, 9 pair. And then this will be a 7. All right. So then 3s. How many 3s do we have? Not a lot. Not a lot. So 2, this equals 8. It could be a 3, 5. See, it can't be a 1, 2, or 4. So this is going to be a 3 and a 5. Which places this as a 9, 5. 6, 8 is not solved. How many 4s do we have? 2. Yeah, so this is going to be the 4. And so is this. Okay, that's a 20. So we have 16. This is a 4, so this has to be a 5. So I can pencil mark 5s there. 9s go here. 7s go here. All right, and then that's a 6, 8. Okay. 2. This is now a 3, and that's going to be a 7. 1, 2. So I can pencil mark these 6s here. This is now a 6, 8, 9 triple. I'm just going to do it. Then 7, 8, 9 still. What do we have? Oh, this will be a 7. And then this has to be a 6. 4 and 7 is 11, so this will be a 9. So I can move that 6, place this as a 6. 1, 2, so 3s are here. Oh, and the reason that I knew that this could only be a 3 cage is because at the bottom you can see the line of the end of the cage, right? So we know that it wasn't 4. And since this one was already a cage, we know that it ended on that. In case you question me. This is a 7. So then we have 5, 8, and 9. So this is now the 9. It's 8, 9. This will be a 5, 8. Oh, 5 is there. So this is going to be an 8 and a 5. Oh, puts the 8 up in the left corner, or the 18 up in the left corner. So then this becomes a 3, 6 pair with a 5, 8 pair here. 1, 2, oh, hang on. So this is going to be an 8, and this is a 5. So we have a 3, 9, and 7, 8. Okay, 1, 2, 3, 4, 5. This is a 7, 8 as well. So that's going to be a 7, 8. So that's a 7 up there. So this is a 6, 8, which puts a 6 here, 8 there, 6 there. And this is a 8, 9, so 8 here, 9 there. Puts a 5 here. 2, 3, 4. So we have a 6, 9 pair we're missing. And up here is a 5, 6, 9. 5, 6, 9. And then this is 1, 2, 3, 4, 5, 6, 7, 9. 6, 7, 9. Okay. So what of those adds up to 18? 5 and 6, so it'd be 5, 6, and 7, right? 5 and 6 is 11, plus 7 is 18. If we do 5 and 9, that's 14, and we need a 4. Impossible. 6 and 9 is 15, and we need a 3. So this is 5, 6, and 7. So I can place the 7 here. That's a 9. So then we have a 6, 9, 8, 7, 3, 9. Clear that fog, baby. 8, 6, 3, 6, and last but not least, in the fog, 5. Yeah, 1239. That's right, baby.